Hey everyone, Mr. Skelton here, back at it for lesson 3 in unit 6, and today we're going to be focusing on two topics. The first one is graphing exponential functions and translating them. Okay, so we're going to be talking about growth, graphing growth and decay. So we're going to be doing both, and then we're going to be shifting them right and left and up and down. All right, and you've had experience with shifting things right and left and up and down, so some of this will look familiar to you. And then the second thing we're going to be working on is writing exponential functions that represent half-lives. You've dealt with half-lives in, I think, like with like chemistry. I would like when elements begin to decay. So half-lives is an example of exponential decay, and obviously it's going to be, your B value is always going to be a half because the life of the element is being cut in half. So when we get to that, you'll see how that kind of works. So let's just jump right into it here. Some of this you already have experience with graphing. We did a couple of those basic graphing ones before. So I'm not going to do all of these. I'm just going to do probably just number 1 and number 2, to be honest with you. So if you had to graph number 1, we could make a T-chart for number 1. And we know that this is exponential growth because of the 2. And again, I always kind of treat this like money. So we're starting with $3, and it's going to double every time we choose to double it, whether it's yearly or daily or whatever. So if I plug in a 0 for x, 2 to the x power, remember you don't times 2 times 3 to make 6. It's 2 to the 0, which is 1, and 1 times 3 is 3, so 0, 3. And I'm going to draw this slightly there in pencil. And then I'm going to put in a 1, so 2 to the first is 2, and that would be 6. So at 1, I'm at 6. And some of you are going to figure out real quick that every time we go, your y values are doubling. 3, 6. So the next one should be at 12 because it's doubling. That'll be at 2. So 2 and 12. Now, I know when we first started learning these exponential growth and decay, I said we're just going to work in quadrant 1, or take the positive values. But when we graph, it also includes the negatives. So I'm going to plug in a -1 here so you can see this. If I plug in a -1, I get 2 to the -1, right? 2 to the -1 is really 1/2, and 3 times a half, basically you're just, if these are doubling, then this gets cut in half, so 1.5. So -1 would be right there. Okay, so 1.5, right? And this 1.5 would get cut in half again when I go to -2, which would be down in here. Now, when I go to graph this graph, you have to be really careful at the bottom. It's never going to cross the x-axis. This right here, okay, where x equals 0, that's called a horizontal asymptote, okay? A-S-Y-M-P-O-T-E. Asymptote. That means this graph is never going to touch it. Now I want you to think about it in terms of money. $3, okay? On the positive side of it, it's always doubling. 3, 6, 12, 24, 48, your money's doubling. But as soon as you cross y equals 0 and you start to go the negative way or get into decay, it's not really decay, it's still a growth function, but your money's now getting cut in half, so $3 becomes $1.50, then 75 cents, 75 cents gets cut in half, then that gets cut in half. You're never going to get to $0 or 0 cents. You're just going to keep getting fractions of a penny, so that's how you can kind of think of it, okay? In red, I'll do number 2 here, so I'll make the T-chart over here to the side, and this is going to be decay. I'm starting at $8, right? And my money is getting cut in half every time. So again, if I plug in a 0, I'm going to get 0.5 to the 0 power, which is 1, and 1 times 8 is 8. So I get 0.8, which is there. If I plug in a 1, I'm going to get half, which is going to be 0.5 to the first power, which is a half. And then a half times 8 is 4. And remember, it's just getting cut in half. So at 1, I get 4, which is right there. And then 4, then when I go to 2, it's going to get cut in half again. And if I were to go to the negative side of this, right? So right now I started at $8, it went to $4, $4 got cut into $2, then my $2 got cut into 1, and then I had 50 cents, right? And then I have 25 cents, and then 25 cents gets cut in half. Well, what happens once I cross y equals 0? This 8 becomes now 16, right? At -1, it's going to be 16 because it's going to start to double this way. And if you plug in a -1 here, 0.5 to the -1 really becomes 2. And 2 times 8 is 16. So that's how that works. Okay? All right, let's flip it over on the back. So now we're going to get into some translations. And we're going to be shifting graphs to the right and to the left. So I want to focus on number 4 and number 5 because number 4 and 5 are the same problems as 1 and 2. Oops, as 1 and 2. Okay? It's just with some translations. So let's take a look here at number 4. I would use pencil on this because I only have one graph for all these and you may want to erase. Okay? So here is the basic function form. Again, this is the same thing as y times a b to the x, but now we have this minus h and k. So let's take a look at number 4. It's the same problem. Let's make a t-chart for it. I'm going to go real light because I may end up erasing this. Before, when I wanted to get my starting point of 3, because remember that's your initial amount, I would just plug in a 0, like I did here. When I plugged in 0, that gave me 3, right? 0, 3. So I want to get back to my starting point of 3. Get on the paper here. So what do I need to plug in? I need to plug in a 3. Because 3 minus 3 is 0, and 2 to the 0 is 1, and 1 times 3 is 3. So at 3, 3, 1, 2, 3, 1, 2, 3, and this is really light, there's my point. If I plug in a 4, 4 minus 3, right, is 1. 2 to the first is 2. 2 times 3 is 6. So at 4, 3, 4, I'm up at 6. 1, 2, 3, 4, 5, 6. All right? And so look at your numbers. 3, 6. You know if you go to 5, what are you going to get? You're going to get a 12. Why? Because it's doubling. So 5, right? So 1, 2, 3, 4, 5. And I'm going to be up here at 12. I'm estimating. But I'm going to get a graph that looks like this. Okay? And again, it's got a horizontal asymptote here. So if you look at this graph in pencil here and then flip it over and look at your first graph here, what do you notice? You may notice that each of the points here were shifted to the right 3 units. So the point that I want to make to you is that this h, okay, is going to shift your graphs to the right and to the left. Now, some students always remember like opposites, right? This is a -3, so if that's a minus or a -3, so they think, oh, it's going to shift to the right 3. These shifts of h and k are just like what you did first semester. It's the same exact thing, okay? And so your h value is going to move it to the right and to the left. Everything else is still the same, all right? Now let's jump down to number 5. I'll use red pen again for number 5. So my initial value is $8. If I cover up this 6, right, it's the same problem as we did before. $8 is getting cut in half, so I'm going to go from 8 to 4 to 2 to 1, etc. But now I have a -6. Now this -6 is representing my k value. So let's just make a quick t-chart for number 5. If I plug in a 0 for x, 0.5 to the 0 is 1, right? Anything to the 0 power is 1. 1 times 8 is 8, and 8 minus 6 is 2, right? No. Yes. 8 minus 6 is 2, okay? If I plug in, let's plug in a 1. So if I plug in a 1, I have 0.5 to the first power, which is 0.5. 0.5 times 8 is 4. 4 minus 6 is -2. So I have 0, 2, which is up here. Okay? I have 1 and -2, which is right here. All right? And if you keep plugging in points, right, we're going to find out real quick that our points are going to keep going. But what I want to show you is what your k value does. Your k value ends up moving this -6, or your k value moves your horizontal asymptote, I just abbreviate, asymptote up or down. And it's always true to the symbol or the sign. So for example, minus 6. So I'm going to go 1, 2, 3, 4, 5, excuse me, 1, 2, 3, 4, 5, 6. So my new horizontal asymptote is right here. So when you look at this, basically every point in red from the first graph is dropped down 6 units. Look at my starting point here, which was at 0, 8. 1, 2, 3, 4, 5, 6 units, right? Because it's minus 6, so that's 0, 2. Look what I have there, 0, 2. So basically everything gets dropped down. I know I didn't do more points, but I want to, for the sake of time, you could keep more points going in there. But this dropped it down 2 points, okay? Now, the last one I want to do, I'm going to do in blue. What happens when your A value, so number 6 is when your A value is negative. Anytime your A value is negative, I'll just tell you right from the jump, if your A value is negative, okay, that means your graph is going to reflect over the x-axis. Okay? So I'll kind of show you, if you notice how this, if you took this graph here, it would just reflect over the x-axis. So minus 5, right? I'll make a little t-chart here with you. Minus 5. Now notice this has no shifts. This does not shift to the right or to the left, and it does not shift up or down. Okay? And so when you look at this, negative 5, so if I plug in a 0, I'm going to get 0, which is 1, right? And then I'm going to get negative 5, so 0, negative 5, 1, 2, 3, 4, 5. Okay? Again, there's no shifts, so my horizontal asymptote is still here. All right? Let's plug in like a 1. Now you may need your calculator for this. So 1.2 to the first power is just 1.2, so 1.2 times negative 5 gives me negative 6. So 1, negative 6 is going to be right here. 1 and negative 6 would be right there. And this graph's going to continue to fall down. If I plug in a 2, so I'd have basically 1.2 squared, and then I'm going to times that by negative 5. That's going to give me negative 7.2. So negative 7.2 to negative 7.2 somewhere down in here. So this graph is going to look like this. Okay? Now, what's happening? Look at your B value. It's still growth. It's just growing in a negative way, right? 5 is growing to negative 6, which is growing to negative 7.2. Those negative values are growing. So it's still exponential growth, just because it's just growing in a negative way. Okay, it's like debt, right? And so that's what the graph looks like. Okay. On number 7, all I want to talk about on number 7 is just how it's going to shift for right now. We can go over number 7 in class if we want to. Just remind me tomorrow. But what are the shifts? This plus 4 is going to shift the graph to the left 4 units. This plus 2 here is going to shift it up 2 units. Okay? Now, I'm going to save also this half-life question for class. So when you come to class, this is going to be our starter problem for today, and I'm going to talk to you about half-lives, all right, because this one's a little tough, and so I want to go over it with you in class. Okay? So the graphing will take some time to get used to. We'll talk about number 7, and we'll talk about number 8 when you come to class. All right? Look forward to seeing you.